Recently, according to the data on NITI Aayog's energy dashboard, India's coal-fired thermal capacity grew to 218 gigawatts in FY24 from 205 gigawatts in FY20. A recent report alleges that in 2014, the company misrepresented low-grade Indonesian coal as high quality and sold it to a public power generation company in Tamil Nadu. What is the current status of India's power sector? Background: the power market is experiencing a growing demand-supply mismatch due to a slowdown in new coal-fired power plant capacity and a lack of effective storage options for renewable energy. This has put pressure on the country's grid managers, especially with increasing power demand during soaring temperatures. Thermal power plants: the share of coal-fired power generation has risen to 75% in FY2023 to 24 from 71% in FY2019-20. Generation by coal-fired thermal plants also increased by 30% from 960 billion units BU to 1,190 BU, and the average plant load factor PLF rose from 53% to 68%. In the past 5 years, thermal capacity addition has fallen short of the government's targets by an average of 54% annually, with the private sector only contributing 7% of new capacity. The private sector has contributed only 1.7 gigawatts, or 7% of the total thermal capacity added in the last 5 years. There has been a push for investments in new thermal power projects, including from the private sector, with a target of adding 80 gigawatts of new thermal power capacity by 2032. Renewable energy: India's solar capacity has seen a significant surge, doubling to 81 gigawatts. Wind power capacity has also witnessed impressive growth, increasing by 20% to reach 46 gigawatts. Setting up a new coal plant 8.34 crore rupees per megawatt is considerably more expensive compared to setting up a solar power plant. Per MW cost much lower. What grade of coal does India produce? High-grade versus low-grade coal. The gross calorific value GCV determines the gradation of coal based on the amount of heat or energy that can be generated from burning it. Coal is a mixture of carbon, ash, moisture, and other impurities. The higher the available carbon in a unit of coal, the better its quality or grade. The most important uses of coal are in thermal power plants and in powering blast furnaces for steel production, each requiring different kinds of coal. Coking coal is needed for producing coke, an essential component of steel making, and requires minimal ash content. Non-coking coal can still be used to generate useful heat for running boilers and turbines despite its ash content. Characteristics of Indian coal: Indian coal historically has high ash content and low calorific value compared to imported coal. Domestic thermal coal has an average GCV of 3,500 to 4,000 kilocalories per kilogram, while imported thermal coals have over 6,000 kilocalories. Indian coals also have over 40% ash content, while imported coal has less than 10%. Burning high ash coal results in higher particulate matter, nitrogen.